In the previous video, we were talking about the forces on the spacecraft. So just to summarize, there are the lift force, the drag force, which we will show in green, and then the weight or the gravity force. So in this video, we're going to talk a little bit more about lift, drag, and weight, how these forces are actually changing throughout the spacecraft's flight. So lift force, as we said earlier, is very similar to the drag force equation. So SCL. So what this says is 1/2 rho infinity V infinity squared S times CL. So what all these things mean. So this rho infinity is the density of the air. So this is called the free stream density. Whenever we put this little infinity sign after something in the subscript, it means free stream. So infinity means free stream. And we mean what we mean by free stream is whatever the vehicle is experiencing in the current air that it's encountering. And normally it just, that's pretty straightforward, but we just indicate that as rho infinity free stream. So V infinity means the free stream velocity squared. So this is velocity. And when we say velocity, normally this refers to the vector computation of velocity. In general, this really just means, for this application, this is just the magnitude of the velocity squared. Or if you were actually operating on vectors, you could just take the vector norm of it, which you can learn more about from if you know more about vectors. Take the vector norm of it and then just square that, and that will give you the velocity squared component. And then S is the reference area. And you might be saying, okay, what is that exactly? Well, reference area actually changes meaning depending on what situation you're talking about. And it actually depends quite a bit on what the coefficient of lift is. So here's the coefficient of lift. So it turns out that they frequently determine, aerodynamicists and engineers who work in wind tunnels will assign some reference area, saying, okay, well, this aircraft has some area, and we'll say it has an area of, say, like 5 meters per squared or something like that, or 5 feet squared, or some area. And then for that area, they compute what the CL, the coefficient of lift, means. So to give you an idea of what this means, it says, okay, so the lift force that the vehicle will experience is equal, or it depends on the density of the air. So if the density is more, then you're going to have more lift. Kind of makes sense that there's more force to lift against, or the medium will exert more force. And then this V squared, or this velocity, that makes sense. The faster you go, the more lift you should have. That makes sense. And what's neat about this is it's not just linear in velocity. So if you increase your speed by a factor of 2, you don't get twice as much lift. You actually get 4 times as much lift. So that's kind of a cool thing. The faster you go, the more lift you generate. And it's according to the square, it's not a linear relationship. And then it's also dependent on how big your object is, how much area it can present to the oncoming air. And then we have this number which kind of characterizes how effective that lifting something is, which we call the coefficient of lift. Now, this coefficient of lift actually depends on a few things. So for airplanes, for example, this coefficient of lift can be changed. Coefficient of lift is a function of several things. So when I say this, it's a function of alpha, which is the angle of attack, and it's also frequently dependent on the domain of flight. And we can characterize the flight regime by this big M. So M is the Mach number. And the Mach number represents how fast you are going through the air relative to the speed of sound in that same air condition. And so if you're going Mach 1, that means you are going the same speed as sound. So that is the sound barrier that you may have heard of before. Now that really doesn't exist. That was just something that people thought back in the 1940s before we could go supersonic. And now we've broken through the sonic barrier, and now we can go faster than the speed of sound. This alpha is the angle of attack. Angle of attack. Finish that A there. So what does this mean necessarily? So let's imagine, here's my favorite example. Lots of aerodynamics books talk about a flat plate. I like to think of it as a big barn door. Big barn doors are kind of funny, and you can kind of think about it. Seems to make a little bit more sense to me than a flat plate, but you can choose whatever. So imagine you have this giant barn door that got tore off a barn in the middle of a storm. So you have this big barn door, and it is flying along. So let's say it is, let's say it's moving this direction. Okay. So this is the velocity direction. So it's forming some angle right now with the body. So we can say, okay, well, here's the center line, and it's extending upwards, and there's some angle between, the direction of the axis of this barn door and the free stream velocity. And we will call this angle that it's flying at. So imagine the barn door is flying at some angle, moving this direction. So we call this angle alpha. Alpha is the angle of attack, the amount of angle that you present to the free stream velocity. So if alpha was 0, for example, you'd be flying on knife edge, straight into the velocity. So as you can imagine, there's probably not going to be a whole lot of lift generated if you, if it's just flying straight across and it's completely flat. And you can kind of have some intuition about this if you ever put your fingers or your hand outside the window of your car. So if you roll down your window, you put your hand out, and if you put your hand flat with respect to the wind and the direction that you're traveling, you don't really feel too much force. You just feel force trying to slow you down a little bit. But as soon as you angle your hand up a little bit, then suddenly, wham, you will get a whole lot more lift force because you present a larger area to this free stream velocity. So the air can impart a large force on you as soon as you present some angle of attack. So it's worth noting that this CL value, coefficient of lift, can change depending on the angle of attack of your vehicle and the Mach number. So the Mach number represents your flight regime, and your angle of attack represents how you're flying into the air. So I think we have covered that in sufficient detail for the lift. Next video we'll talk about how drag behaves. Drag behaves very, very similarly.